The goal of this video is to assess the efficacy of the heart, specifically if the left or right ventricle is pumping adequate amount of blood per unit time. Cardiac output is the volume of blood ejected from one ventricle per unit time. So we'll just use the left ventricle as an example. Cardiac output in this example would be the volume of blood ejected from the left ventricle per unit time, generally determined by heart rate times stroke volume. Heart rate is the number of times the heart or ventricle beats per minute. Stroke volume is the volume of blood ejected from one ventricle after one beat. If we look closer at this, stroke volume is defined as N diastolic volume minus N systolic volume. So if we look just at these two numbers right here, 120/80, there's two numbers when we're talking about blood pressure, a top number and a bottom number. The top number represents systole, and the bottom number represents diastole. Systole is when the heart is contracted. Diastole is the relaxation phase of the heart. So once again, if we're talking about ventricles, systole is contraction of the left ventricle, or the pressure. The top number is the pressure of the left ventricle when it is contracted. Keep in mind, when the left ventricle is contracted, the volume of that chamber has gotten smaller, the pressure increases. The bottom number, diastole, is the pressure within the left ventricle during relaxation. The volume of that chamber has gotten larger, the pressure has decreased. Once again, systole contracted, diastole relaxed. So if we look back at N diastolic volume is the volume of blood in the left ventricle at the end of relaxation, just before the left ventricle is about to contract. And that volume tends to be about 135 milliliters. N systolic volume is the volume in the left ventricle after one contraction. So after one ventricular contraction, there is still some blood remaining in the ventricles, in this case in the left ventricle. So to determine stroke volume, we just subtract ESV from EDV, and that'll give us the amount of blood that was ejected after that one contraction. So keep in mind, N diastolic volume is the whole volume up to this red line. And if we subtract what's left after contraction, that gives us the stroke volume, which that would give us a stroke volume of 70 milliliters, which is a fairly typical stroke volume. Once again, stroke volume is the volume of blood ejected from one ventricle after one beat. Now we can apply that to cardiac output, which once again is heart rate times stroke volume. And let's just say a heart rate of 72 beats per minute times a stroke volume, which we just suggested was 70 milliliters per beat. To determine cardiac output, we just cancel out the beats, and then we're left with 5,040 milliliters per minute. And if we convert that to liters, that would equate to about 5 liters per minute. The cardiac output from the left ventricle at 5 liters per minute is the same as the volume of blood in our body. So we are pumping out our whole volume of blood in our body from the left ventricle over the course of 1 minute. That is cardiac output. In the next video, we'll talk about how cardiac output can be modified.